Hello and welcome to the last lesson. So this lesson is for 22.3 and 22.4. This is going to be the last set of homeworks that you have to do. It is also the last set of exit tickets you have to do. So pretty exciting. This is where we would have been normally ending this week if we had been in school just about 2 weeks after spring break. So pretty exciting. What I'll point out, remember that 22.1, 2, and 3, the homeworks and the exit tickets are due tomorrow. And then 22.4, I believe I put as either Sunday or Monday. Other than that, next week we're going to transition. So Double Dose is still going to be doing Khan Academy. For the core class, I'll let you know what you're going to be doing. Basically, we're still going to be doing some kind of review, just to kind of recap, go over what we've been doing all year. And you're looking at roughly, I'm approximating here, maybe 2.5 hours of work per week at the most. Probably a lot less than that for most of you. That high estimate is really just in case you've been kind of behind and you really need to work harder as far as going over things, but otherwise you should be fine. All right, so first of all, as we go into this lesson is about two things. First of all, it's about how to find the solution of a quadratic equation using yet another strategy, another technique, another formula, so to speak. So remember, we've done factoring, we've done taking the square root, we've done completing the square, and now this is about using the quadratic equation. So the quadratic equation is one of my favorite ways to solve a quadratic equation because it always works. Remember we talked about factoring. Sometimes equations are not factorable. We talked about taking the square root. Sometimes it's way too complicated to do that. Completing the square actually does work almost all the time, or all the time now that I think about it, but it can often be very, very difficult to do depending on the type of problem it is, and it is rather long and complicated. The quadratic formula will work no matter what. So if you had to pick like one technique or one method of solving a quadratic equation that will always work no matter what, this is the one. It involves memorizing a formula, which I'll give to you later in this lesson. But once you know the formula, you pretty much know it for life. It's one of those things that it's like riding a bike. You learn it once and then you don't forget it. So this will be something important, especially for those of you that are going to be pursuing magnet schools or other high-level programs in high school. So first of all, when we do quadratic formula, we're going to start with an idea of something called the discriminant. And so that's the word right here, so the discriminant. The discriminant's going to tell you, and again, it's almost like a shortcut to doing quadratic formula. It helps you speed it up at least. The discriminant tells you how many solutions there are going to be at the end. And so remember that quadratic equations can have two solutions. Sometimes they only have one solution, and sometimes they have no solutions. So by finding the discriminant, you're going to know before you even start the quadratic formula how many solutions you're looking for. So like for example, if the discriminant tells you there's not going to be any solutions, well, you can just stop. You don't even have to do the whole formula because you already know there's no solution, right? So usually you want to start by figuring out what the discriminant is. So the discriminant, and make sure you write this down, it's written down there too, but the discriminant, the formula is b squared minus 4ac. And in general, if this is positive, or let's say greater than 0, then there are two solutions. If the discriminant equals 0, that means there is one solution. And if the discriminant is less than 0, that means there are no solutions, 0 solutions, okay? So how do you find b squared minus 4ac? Well, first of all, pause the video and write that stuff down because I'm about to erase it. 5, 4, 3, 2, 1. Okay, erasing. So let me show you how to actually do this using the discriminant. So let's look at the first example, which says x squared plus 5x plus 1. Right over here, x squared plus 5x plus 1. This is the first problem. So I'm going to go ahead and label everything. A is an invisible 1 in front of the x squared. B is the 5 in front of the x, and then C is 1. I'm going to plug all of that into the discriminant formula. So b squared, it's going to be 5 squared minus, and by the way, you should probably put this in parentheses, minus 4 times a, which is 1, times c, which is 1. So 5 squared, that's 25 minus 4 times 1 times 1. That's really just 4. 25 minus 4 is 21. Now you'll notice you don't actually need to get the number. All you got to realize is that this thing is a positive number. Like if the discriminant's like really complicated and you don't really want to find out exactly what it equals, it doesn't matter. You don't need to know exactly what it equals. You just need to understand, is it positive, negative, or does it equal 0? But because it's positive, that means my final answer is going to have 2 solutions. 2 solutions. I can't spell 2. Why isn't this working? 2. Come on. 2 solutions. Okay? Because the discriminant is positive. So using what I just showed you, go ahead and find out for the next 2 examples on the left, are they going to have 2 solutions, 1 solution, or no solutions? Okay? All right. So then, once you know that, you actually already know part of the quadratic formula. So let me write the formula for you. And again, this is something that you need to memorize. Here's the formula. It is x equals negative b plus or minus the square root of b squared minus 4ac. That's all under the square root. All divided by 2a. 2a. That is the quadratic formula. You need to memorize that. Looks complicated, it's not. In fact, notice you already know a big part of it. You see under the square root, that's the discriminant, right? So that's it. That's all there is to it. So I'll do the first problem with you / for you. Actually, you know what? Let me do the second problem because that's going to confuse more of you. So the second problem says, and I'll start it over here on the left in case I run out of space. The second problem says 2x squared equals 8x minus 5. So the first thing I'm going to do is I'm going to get everything on the same side. That's a really important step to doing the quadratic formula. So I'm going to subtract the 8x and I'm going to add the 5. And I'm going to get 2x squared minus 8x plus 5. And then on the right side, all I'm going to have left is equal 0 because there's not going to be anything left because I moved everything to the left-hand side. And then what I'm going to do is I'm going to label everything. So a, the number in front of x squared is 2. B is negative 8, and C is 5, okay? Then what I'm going to do is I'm going to find the discriminant. So, by the way, if I were to label all this, step 1, get everything on the same side. Step 2, label A, B, and C. Step 3, find the discriminant. So, B squared minus 4AC. So, that's going to be negative 8 squared minus, I'll put it in parentheses, 4 times A, which is 2, times C, which is 5. Negative 8 squared, that's 64. Minus 4 times 2 is 8. 8 times 5 is 40. So the discriminant is going to be 24. That is a positive number. That means at the end of this, I should have a total of 2 solutions. Step 4, I'm going to rewrite the rest of the quadratic formula. So the quadratic formula says that x, which is what I'm looking for, equals negative b. b is already negative 8, so negative 8, that's positive 8. Plus or minus the square root of b squared minus 4ac. That means the square root of the discriminant. So I'm going to put 24 in there, all divided by 2a. a is 2, 2 times 2 is 4. Okay, step 5, simplify. So let's see how we're going to do this. 8, I'm going to leave alone, so x equals 8. Now, plus or minus, I'm going to simplify the square root. If you'll recall, square roots can be broken up into smaller square roots. So like the square root of 24 is the same thing as the square root of 4 times the square root of 6, because 4 times 6 is 24, right? So I'm going to write that out. So it's the same thing as square root of 4 times the square root of 6. Now you're wondering, why am I doing that? And the reason I'm doing that is because I want to be able to simplify this. Square root of 24 is irrational. I cannot simplify it. But the square root of 4 and square root of 6, at least one of those, cough cough, the 4, is simplifiable. That means I'm going to get x equals 8 plus or minus, what is the square root of 4? That's 2. Square root of 6 is going to stay, all divided by 4. Now this I can work with. I can actually simplify everything. There's 3 terms here, by the way. Here I'll call this term A, here's term B, and here's term C. All of those terms, A, B, and C, By the way, I don't want you to get confused. That's term A, B, and C, right? All of those terms are divisible by a common factor of 2. So that's what I'm going to do. I'm going to divide everything by 2. I'm going to get x equals 4 plus or minus 2 divided by 2 is gone, so just the square root of 6 all over 2. Okay? Some people would simplify that further and kind of just be like, oh, well, that's 2 plus or minus square root of 6 over 2, and I already said plus or minus, but some people will simplify that more. I'm okay with leaving it like this. Khan Academy ebook, just be careful for how they simplify it, but that's it. So using those steps, pause the video, take your time, go back, and make sure you know how to do the quadratic formula. Okay? All right, so here's another example. But on this example, notice that it says something different. It says to investigate the different possible ways to solve this. So that means you're going to have to decide, how are you going to solve this problem? Are you going to factor this problem? Are you going to use the square root method? Are you going to complete the square? I'm abbreviating. Or are you going to use the quadratic formula? Each of these has their own unique advantages and disadvantages. Now, and this is kind of where you want to take all this, right? So over the last 2 weeks, basically, you've been learning about how to solve a quadratic, and actually more than 2 weeks, but you've been learning how to solve a quadratic using each of these methods. Now, and this is going into the third and fourth exit ticket, really, the fourth exit ticket in particular, is, well, which one of these are you actually going to use? Like, how do you know which one to use if it doesn't tell you which one to use? So let me go through this. Factoring. Factoring is often, as I've said, the easiest, or at least one of the easiest ways to solve a quadratic equation. It's very simple. However, not all the time is something factorable. What I look for is specifically the A and the C. So in this problem, I see that A equals -3. I see that C equals 7. That throws things off. So if A is anything other than 1, like an invisible 1, usually I don't like factoring it. Is it still factorable? Possibly, but it's not always the best idea to factor it if the A is anything other than a positive 1. Okay? Because of course then, other than just looking at the B and the C, like normally you'd ask yourself, okay, what multiplies to the C, what adds up to the B, but that only works if the A is a positive 1, right? Otherwise then it becomes more complicated, and yes, we did practice some more complicated examples, and when you get to Algebra 2, you'll do some more complicated examples, but for our purposes, I mean, we're just in Algebra 1, if A is not 1, then maybe that's not the best method. Okay, square root method. Square root method basically says you want to get the x squared by itself on one side and you want everything else on the other side. Now, that's very useful when there's no other term there. Notice that there's a linear term. There's a 5x in there. That throws things off. So like, what are you going to do? You're going to get the -3x squared by itself. I mean, you still have a 5x equals -7. Like you can't take the square root of that, right? Like you don't know how to do that. At least not yet. That's more of like a pre-calc type thing. So you're not at that level yet. Square root here is not simple. It's not easy. So those two, first of all, it's method number 1, method number 2, if you want to call it. Those are like the easiest 2 ways to solve quadratics. But in our case, maybe not the best ones here because we don't even know if they're possible. Completing the square. Well, generally speaking, it'll always work. But again, what you're trying to do is you're trying to make the left side of the equation a perfect square. So again, you'd kind of start by isolating, right? You get -3x squared plus 5x on the other side. You'd have your -7. Then you ask yourself, what can I add to both sides so that the left side is a perfect square, and then I can factor it. But that really only works kind of like factoring if the A is a 1. That's like the easiest way to do it. If A is not a 1, then remember what I taught you in the last lesson, you want to make it a perfect square. So for example, you could multiply everything by, I don't know, -3, and then you'd get, okay, well, that'd be positive 9x squared minus 15x equals positive 21 if you multiply everything by -3. And then, you could take it from there. But now notice these numbers are getting fairly large, fairly complicated. So in this particular example, I would just use the quadratic formula. So I would just be like, okay, well, A is -3, B is 5, C is 7. So basically my logic is if it's super easy and I see it off the top of my head, I'm going to factor it. Okay, if it's not factorable, but it's maybe a really simple form, a simple structure to the equation, there's not a whole bunch of terms and everything, then I'll do the square root method. If it's reasonably well isolated, maybe it's, I know it's going to become a perfect square, then I'll do completing the square. Otherwise, this is not, I don't want to say it's my favorite, but I mean, it always works. I mean, literally, identify the A, B, and C, plug it into the formula. That's all you have to do. Obviously, you have to be reasonably good at plugging in numbers. And this actually goes back to the beginning of the school year, right? Like being able to square things, multiply them, get the negatives right. I should probably, mention also that this should have a parentheses. That's like never shown in a book or on Khan Academy, but don't forget that when you subtract it, it should be as a unit. Okay, so that's how I would decide if I were you. So me personally on this problem, I would use the quadratic formula. Do you have to use it? No. Another realistic option would be completing the square. I personally would not even try factoring or square rooting on this at all. So there's a bunch of text on here, and it says pretty much what I just said. You can pause this video and read it if you'd like. It's from your ebook in the lesson. Otherwise, I'm going to move on. Here's another problem, and again, remember you have 4 options. What I'd like you to do is really take your time, pause the video, and figure out which method would you use and why. So you pause the video. You're not listening to me right now because you paused the video, so I'll wait a few more seconds. All right, so if it were up to me, I would use the square root method on this one. Why would I use the square root method? There's no linear term. It's missing a whole term. It's not ax squared plus bx plus c. It's just ax squared plus c. It doesn't have a bx in the middle. So if I were doing this problem, I'd say that, okay, well, 16x squared equals 121. How'd I get that? Well, I added it to both sides to move it over there. Then, if you take the square root of both sides, well, that's going to be 4x, because the square root of 16 is 4, and the square root of x squared is 4. That equals plus or minus 11. That's it. And so divide both sides by 4, and you get x equals plus or minus 11 over 4. See, it takes not even 2 lines if you did half of that in your head, right? So that's what I would use on this problem. I would use the square root method. What would you use on this method? Me personally, I would probably try factoring it. And again, you can pause the video and figure it out on your own. Why would I factor it? Because I see simple looking numbers like a 10 and a negative 30, and I kind of think to myself, oh, that can't be that bad. Like, I mean, maybe that's, I don't know, negative 15 and positive 2. That's probably not it, actually. But, try different numbers out. If, let's say you try it 2, 3, maybe 4 or 5 times at most and you can't get the factors, move on with your life. Try something else. Maybe completing the square, maybe quadratic formula. But me personally, I see numbers like a 10 and a 30, which seem reasonably simple, nothing that complicated. I would try factoring first. Okay, so at this point, you should be able to do the last 2 exit tickets. The third exit ticket, if you'll remember, is about quadratic formula, and the 4th exit ticket is about, well, pick a method. Pick one of the 4 methods we know, and see which one you feel most comfortable with, which one would be the best idea. Okay, and that's it. We're done with exit tickets. We're done with homeworks. As of next week, we're going to be moving on to other review modules. So we'll address that next week. But anyways, bye.